Still chasing some QRM in a garage at the moment, and we've got a little bit of a strange noise coming from the garage. It has some electric door openers, but we're not yet quite sure what's responsible. But I do have the spectrum analyzer set up on the floor here. There's a couple of birdies on the 0 to 3 meg mark and another big burst around the 7 to 8 meg mark, and we're trying to find out what it's coming from. And this noise seems to be associated with the main supply. Wherever there's a power cable, we're seeing that noise being injected into the supply around here, and we're not quite sure what the source is yet, but we're going to get to it. We've got this noise source, and let's see if the lights are doing it. Nope. Radio shed. Nope. That's the RCD for light and power.
This shed?
Ooh.
Nope.
That's something in this shed.
It is, isn't it?
Let's put that back on again. There's our noise source again, but it's coming from these roller doors. Now if I turn those off, there's the receiver. And she's quiet. So, beware of the roller door supplies. And that's the second one. There's another unit up here, and it's creating even more noise. It's got a power switch. Okay, I've got a power switch here. Wow, that's nasty. Okay, now we've found the source of the interference. We're 1,000 kilometres south of where we were a moment ago. We've removed this motor system from the garage door, and we're going to do some further analysis on it to try and find out exactly what inside is causing the noise. So the unit has been removed from the roller doors. It has a little drive mechanism on the side to drive that door, and inside it has a power supply. Presumably the power supply is the source of the noise. Alright, now for some analysis. We've got our little test bed here. Let's see what it does for us. On the screen it's looking clean at the moment. Our supply voltage is regulated. We're feeding it with 240 volts, but perhaps at the site it's experiencing a higher voltage. That's a possibility. Under certain conditions it's not unusual to experience voltages above 250 to 260 volts. So I've dialed up 260 volts here. Oh, still no reaction. Okay, so it's time to leave this thing running for a while and see what happens when it warms up. Perhaps it'll generate that interference then. The unit is very unstable, but the interference did appear for us. It showed up as a strange series of pulses high up into the VHF part of the spectrum. We wondered about the integrity of the AC mains at the garage location, so we plugged a data logger in for a week to check it out. While it did frequently go over the 250 volt mark, it did stay within the acceptable range that a power company would permit. We've just put the unit on a bench and it seems to take a while for the lights to come on, so I suspect that there's some serious power supply problems inside. It's no longer responding to the remote control either. We'll turn the power off and pull it apart. Inside we've got a power supply, a motor drive unit, and a control logic with the receiver. So the unit's been disassembled, and here is the power supply unit. It says it's input 100 volts to 240 volts, so it may have problems where the supply gets higher than 240 volts. It says that the output's 24 volts DC at 2 amps, but it's only producing just over half of that, so it definitely has some issues inside. It also says, attention, do not disassemble. And that sounds like a bit of a challenge to me. We've reached a point with this power supply where we've concluded that it's just not a very stable design. 2 of these have failed. Even the original one was changed once. But I suspect I know what's going on with the noise that it was producing on the power rails. The power supply is collapsing from its 24 volts down to a lower voltage. As soon as that happens, it tries to recover and return again to 24 volts. But it's doing this multiple times per second and putting spikes on the power lines. That's what we're hearing is creating a lot of the motorboating interference on the power rails. The best solution in this situation is to replace the power supply with a new one, hopefully a better one than what was in here before. After a bit of shopping around, we found a good match on the Element 14 website. This one has a 265 volt rating and should last a lot longer than the original unit. So another week has passed since we last worked on this system. We did manage to prove that the original power supply unit here wasn't very satisfactory even when it was at its prime. They just don't seem to be lasting very long, and they do generate a lot of noise. So a decision was made to replace it in its entirety, to remove this module, which is a 2 amp 24 volt module, and to replace it with an aftermarket one from a different supplier. Hopefully this one will be a little bit more efficient and a little quieter as well, but it should fit within the same storage space. Now to the test lab to see how much radiation is coming from this unit. While things are electrically quiet here, I'm going to leave the door open for this test because if the door is closed it won't pick up the remote control commands for the keyring. There we have it, a little bit of noise around the 2 meter band while the motor is in motion, but the radiation is not a lot and is only happening while the door's in use, so that should not be a problem at its resting location. So it's ready for the final installation back into the field, and I believe the problem has been solved.